Hey, g'day, it's Closeup here. Thanks for joining me today. I hope you enjoyed the mini wildlife documentary. Now, I post this stuff because a lot of my audience is from outside Australia, and a question I often get is, do you see kangaroos? Do you see koalas? Well, yes, we do, because we live on acreage and we live very close to a national park. And that sort of wildlife does appear from time to time around our house. And I must say that the big goanna we saw today was a bit of a surprise. We know they're around, but we don't often see them that close to the house. Now, the subject of today's video is part 2 of how to fit a TouchDRO system to a knee-type milling machine. Now, I own a Bridgeport, but you can use this system on just about any type of milling machine or any type of lathe, or for that matter, a thicknesser or a table saw. Anything where you may want to measure accurately the position of a cutter or a workpiece. So in the last episode I showed you how I fitted a standard 10-inch Android tablet to an arm so that it becomes the visual display for the unit. In this episode we're going to focus on fitting the rest of the hardware, which is the Bluetooth adapter and also the scales. A while ago I did a video on how to fit one of these iGaging EasyView DRO scales and the associated LCD display that goes with that. And for use on a quill on a milling machine, this is fine. Alright, it works to within 1/100th of a millimeter, and that's about 3/10 of a thou, so I'm happy with that sort of resolution. But on an X and a Y axis on a milling machine, you often want to do more than that. So you may want to do bolt hole patterns or linear patterns, you want to do axis halving and that sort of thing, and these are a bit limited in that respect. So what I decided to do was to buy 2 more of these, one for the X, one for the Y axis, and fit those, and I'll show you how I did that. So here's the general arrangement of the Y axis scale on the Bridgeport, and these fittings that hold the scale on either end, they've been custom made. Here's a better view of one of the fittings on the Y-axis scale. So this is all machined from aluminium stock. It's been anodized in black, and this clamping arrangement here is split just at that point there. And there's a rebate in both the top and the bottom half of the clamp, and it's been sized so that when you tighten up these 2 socket head screws, it just pinches down on the scale material. Now if you need to, you can put a piece of shim in there just to make sure it does lock down nice and hard. This slot here allows for some vertical adjustment when you're setting up the scale, and this little pillar here or standoff is threaded, and there's a threaded hole already in the knee at both ends. This is probably done at the factory, and I simply screwed in a length of, I think it's 1/4 by 20 stud material, and then screwed this pillar down onto that nice and hard, and then everything else was assembled onto that. Here's the reed head here. It's actually been turned back to front. Now that was just for convenience, so I could get this 2-part bracket attached to that, and this section here is made of steel angle and it's screwed into the end of the saddle, and then a second bracket, this one is made of aluminium, it lines up with some pre-existing holes in the back of the reed head. And there's our wire coming out the bottom. When you buy these iGaging scales, they come with some hardware. This little Z-shaped bracket here is made of pressed steel, and it's to take the end of the scale material. And there's a pair of clamping screws there which you can use to fix that down in much the same way that I've done with that machined aluminium hardware. The only problem with this is that these bends are not truly 90 degrees. So when you fit all this up to the machine, the actual scale has a tendency to spring away from the axis of the machine. Here's a video of what that looks like when I fitted it up to the back of the table. And this little other Z-shaped bracket here is for fitting to the back of the reed head, and this would normally be bolted to the moving part of the machine. The other thing I should mention is you can actually cut these scales to length. So this is the offcut from the X-axis. It was way longer than I needed it, and it's just cut off with a hacksaw, and you can file the end, and it has no effect whatsoever on the way that the scale works. Now try doing that with the glass scale and it's all going to end up in tears very quickly. But yeah, these do allow you to do trimming and adjust them to length, and for that reason they only come in 4 sizes, so you can get them in a 6-inch, 12-inch, 24-inch and a 36-inch, that's right. This was the offcut from, I think, the 36-inch scale. One thing I can't show you in this video is the ZAxis scale, which is going to connect the knee to the column. Now, unfortunately, the company that I purchased my other 3 scales from, which is Timbercon here in Australia, are completely out of stock of the 24-inch scale, which is the close to the correct size for this application here. And at the end of the day, I had to suck it up and buy a 36-inch scale, which is way longer than what I need. The good thing, like I said, is you can cut them down. Here's the offcut here. And if you look carefully, you'll see that this is just an aluminium extrusion with a recess, and there's some sort of a metallic and plastic compound that's been stuck down into that recess. You can peel this right up if you want to. And these little things that look like piano keys are that's what the read head actually reads as it moves along. Now, I'm not sure exactly how it works. It is a capacitive scale, so I'm guessing these are some sort of discrete capacitor or some sort of discrete metallic film composite that the read head can register. So yeah, look, we're just gonna have to wait and see. When I get this scale attached, which should be fairly straightforward, we can then add whatever this scale reads to whatever the quill reads as a summed Z-axis count. This is what it looks like at the back of the table. This is the same mounting hardware that you saw on the Y-axis. The only difference is that it's screwed directly to the back of the table. And that's for a particular reason. You want to keep this scale as close as you can to the back of the table. So that gap there should be minimal. And the reason for that is that when you wind the table all the way back to the column, you don't want this to crash into the column at all. So as it turns out, I got this as close as I can possibly get it and still have it work. And we'll have a look at the read head in a minute. And one of the good things about these iGaging scales is that they are slim and compact. And the other thing is that I'd imagine that if you were to crash this into something, it would just simply deform. Whereas with something like a glass scale, you're going to break it first time. So I haven't tried it. I hope I never find out, but I'd imagine that that's what happens. So here's how I've got the read head mounted on the back of the table. And this is all set up so it's very, very close to the back of the table. There's about a 3mm gap there at the top. And this little aluminium bracket drops down from the back of the read head and is screwed to the stationary part of the saddle with a single screw. Everything's locked down nice and tight. And as you can see, when you move the table, the actual scale moves through the stationary read head. Now, all of these scales are working now independently on their own LCD displays, but what we want to do now is get all of this integrated with the TouchDRO Bluetooth adapter and then have that information display on the screen. Alright, before we go ahead and try and integrate this, I just want to show you a close-up of the board here. Now, this is the one that I purchased from Yuri as the pre-made option. In my view, that was the way to go for me. I don't really want to be soldering something this small together and troubleshooting it later. Now, this has inputs here for X, Y and Z axis, but it also has a fourth axis which is labelled as W, but that can be assigned to any sort of scale that you want. Now, in my case, this will be connected to the larger scale on the knee of the mill, and within the TouchDRO app you can sum these two scales together, and that's the plan for me anyway. Now, there's a USB port here for 5 volts in, and these are all standard USB ports. And if you've got a Samsung tablet, the power supply, if you've got a spare one, that will actually power up this board quite easily. Now, there are also inputs here for a probe and a tachometer, and Yuri was kind enough to send me a couple of these Hall effect sensors Now these can be used in the spindle of your milling machine, and they'll read a magnet or magnets, and then using the correct settings inside the TouchDRO app you can show RPM or spindle RPM on your milling machine. Now at this stage I'm not going to do that. I've got a variable speed head on my Bridgeport anyway with the RPM display on the front, and that's close enough for what I want to do. But it's nice to know that this is an option if you have a TouchDRO system. Next thing we need to worry about is how we're going to protect this little Bluetooth device here while it's on the milling machine from chips and coolant and that sort of thing. And my first thought was some sort of an aluminium case for this, and I asked Yuri about it and he said probably not a good idea, because this being Bluetooth, any sort of metallic case is either going to block the Bluetooth signal or degrade that signal, and he suggested that some sort of a plastic case was better. Now, as soon as I heard that, went ahead and I started designing a case to take this little module here, and then about a day later he sent me a link to this one. Now you can get this on, I believe, Thingiverse, but I'll put the link in the description below, and you can download that and go ahead and print it. Now this is printed in PETG filament, which is nice and tough and durable. It's got a couple of mounting lugs here. There are already sockets, or at least clearances in the side of the case there for the ZAxis sockets, and one here for the 5-volt power in, and there's provision on the back there to take M3 nuts so that you can tighten the screws down through the board and through the lid. And this is designed really neatly. It's sort of a very tight fit, and to get the board in there you've got to sort of put it in and then push it across and forward. Alright, so it sort of goes forward that way, across that way, so that these USB sockets are exposed through the openings in the side of the case. Here's the lid. Now the lid that Yuri sent me had some 3D text actually printed into the case itself for the ZAxis labels and the 5-volt power in, plus the logo. And I looked at that and I thought I could probably do a better job with a laser cut and laser etched label for that. And I modified the lid so that I could print that recess into it. And here's the laser cut and laser etched label that you saw me making earlier. So to assemble this now, you can just put some M3 socket head screws, or whatever you like through there really. You can use Phillips head screws if you want, and we can just screw all that down, and that makes a nice neat package which can be screwed somewhere to your milling machine. So let's go and figure out where this is going to go now. Right, the next piece of the puzzle here is how do we mount this Bluetooth adapter and where does it go? Now I've tried this running in various locations. So I've tried on the front of the arm or around the back of the arm. I've put it underneath the collet rack at the back of the mill, and it functions equally well in all those positions. But at the end of the day I have to think about where the various wires are running. Now these are the 3 wires from the scales that I already have attached, and there'll be the 4th one when we put the 4th ZAxis scale on. And it seems logical to run them through the bracket at the end of the arm here. Now one of my viewers suggested that I should run all these wires down the center of the arm through the hollow space in this piece of tube here. And when I read that I thought, why didn't I think of that? But as it turns out, this large pivot bolt takes up nearly all of the space on the inside of the arm there, so there's just no room to get the USB plugs into that gap. So what I'm going to do is to route the wires down the back of the arm. Now I've 3D printed some little clips, and these will take 6 wires. I've got some that'll take 2 and some that'll take 1, and that's going to help me to keep all this tidy. But anyway, let's go ahead and get this screwed on. Okay, well that's mounted solidly enough, and let's think about getting all the wires routed through now. I just jumped ahead a bit and I put these clips on the back of the arm here to manage all these wires. Now this at the moment is a mess, I know that, and I'm going to have to either bite the bullet and shorten these wires or coil them up in some way with zip ties and so on. But for the moment, not too worried about that. Well, that's what it looks like from the front, and I know this is not very tidy, all these wires hanging down. I need to do something about that. But for the moment it's working, and when I get the 4th scale for the knee, that'll plug into this socket here, and then we'll worry about tidying up the wiring at that point. But I've got the power cable running into the TouchDRO adapter here, power for the tablet going in here, and at the moment it's all working. So there's Y, there's Z, and that's X, and you'll see these these numbers flickering from time to time. Now that's not to do with TouchDRO, that's a function of the iGaging scales. So they're not as accurate as a glass scale. You're not going to get that sort of resolution out of them. Now if you want glass scales and the accuracy that goes with that, you can buy a version of this board that will work with the glass scales. But for me, I'm happy with these iGaging scales and I can make them work with what I do. And if I change to metric there, you may notice that it sometimes flickers. All right, so this one here is flickering backwards and forwards a bit. And that's telling you that, in this case here, for example, 3.36, you may see it flicker to 3.35. That's just telling you that the read head is right on the junction between the 3600s and the 3500s. If it's stable, like the X, then it's sitting right in the middle of that range and you won't see that flickering happening. Now I'm still getting used to it. I notice that sometimes it sort of gives you a weird number, just pops up and then it goes back to a stable number like we've got here. I think that's to do with grounding, but if it becomes a real problem, I'll get in touch with Yuri. I know he's got some resources on his website for dealing with that. But for the moment, I'm not going to go into TouchDRO itself. I'm still learning it, and yeah, you saw that top one. I don't know what that's about, but it does go back to the correct number. When I get a bit more confident with it, I'll show you some of what I know. But for the moment, we can switch backwards and forwards, inch and metric. We can zero all of the axes. You can do axis halving. So in this case here, we can take a reading on, say, a part, do the half function there to find the exact center of it and so on. It's also got a tool offset function. It's got a bolt hole function and a step and repeat function. And all of those are graphical, which is very, very interesting. And hopefully in the next video I'll show you some of those functions. Now that I've got that system working, I will have 3 and eventually 4 of these LCD displays. Now this is the one that I had originally fitted on the quilt scale. I just took it off because, well, it's surplus now. And if you want one of these, or 2 or all of them, let me know in the comments below and I can send them to you. So these are practically brand new, 3 of them are, and they're just going to sit around here in the workshop and get in the way. Now you may have broken one of these and you can make use of one, or you may want to hack it and do something else with it. But the annoying thing is that you can't buy just these scales on their own. You've got to buy the LCD display with it, and that sort of adds to the cost, and in this case I didn't need them. But there you go, they're free for the taking. Just let me know and I can send them to you. That's all for this episode. Thanks for checking it out, and in the next one, like I say, we'll do a mini tutorial on TouchDRO. So join me for that, and hopefully by then I'll know a bit more about how this all works and I won't look like a complete and utter fool. Alright, it's Prezzo signing out. Thanks for joining me today, and I'll see you on the next video.